Two and a Half Admins, episode 45. I'm Joe.
I'm Jim.
And I'm Alan.
And here we are again. And before we get started, yet another blog post to promote, Alan, this time FreeBSD performance observability.
Yeah, so this is talking about some of the tools you can use on FreeBSD to see what your system's doing and how fast it's doing it and so on, which is usually the first step to figuring out when something isn't as fast as you expect it to be. You can start looking at why. And, is it the throughput isn't as high as you want, or is the latency more than you would expect, or what is going on? And being able to look at that, oftentimes a pattern jumps right out. It's like, oh, that one hard drive is taking twice as many milliseconds as the other ones to write the same amount of data. It's probably what's slowing things down.
Will it tell you if Brendan Gregg is screaming into your disks?
If you're watching it, you could distinguish between screaming and not screaming, which is all that you really need.
Nice. Well, link in the show notes as ever. Alan, you found an article by Bruce Schneier and Tara Wheeler about vulnerabilities in weapons systems.
Yeah, so this is Bruce talking at a conference. The main point is he was looking at the U.S. military in particular and their ill-preparedness for cyber warfare. He's noticed that over the past decade, many different militaries have established, cyber commands and developed cyber war doctrines. But they're mostly thinking offensively, what are we going to do to the other guys? But in their own war games, they never seem to focus on what are the bad guys going to do to us? Or even thinking about how much the current military command structure revolves around being able to use the internet to schedule FedEx to make a delivery and things like that, where in peacetimes that works perfectly fine. But you kind of need to assume the internet's not going to work properly during a full-on cyber war with a near peer. And then gets into more complicated things like drones that get hijacked in midair and go target other things, or vehicles that won't start, right? In last week's episode, we were talking about car manufacturers being slowed down by a lack of chips. Well, it turns out if there's a chip in it, it might be possible for someone to make it do something other than what you wanted it to do. Whether that's over the internet or because you bought the chip from a country that wanted to sabotage your tanks or whatever.
Well, we try not to get too heavily into politics here, but I would like to point out that, in my opinion, a lot of this comes from the fact that for at least 20 and probably more like 30 or 40 years now, we, meaning the USA, we have not been designing our military or its operations or its hardware around the idea of war with near technological equals. We have been increasingly specialized in beating up on people that we have an enormous technical advantage over. It's difficult to say exactly what a modern war between first-rate powers would look like because we haven't seen one in a very long time now.
Yeah. And, on top of serious concerns about, all the telephone equipment is made by a company that maybe is influenced by another country's military and might have backdoors in it, or the supply chain stuff we were talking about. But then on top of that, you have the problem of even just general cybersecurity of stuff made in the US. It turns out the Department of Defense doesn't really understand how to include in the statement of work for their new vehicles, oh, this has to be cyber war proof or hardened against computer attacks. And if they can't put it in the requirements correctly, then the manufacturer is not going to bother with it if it's not in the requirements. And so, they found that when they looked at it, I think it was 2018, there were 0% of the procurements had requirements against actually having some kind of security testing and hardening. And then it eventually went up a little bit, but it seemed like it was not really being taken seriously.
I don't want to be a complete defeatist here, but you folks are familiar with the Peter Principle, right?
I don't think so.
The Peter Principle basically is the idea that you keep getting promoted until you're no longer competent to do your own new job after the final promotion. And that's when the promotions cease. And a lot of this concern about nothing being designed secure is not at all new. I mean, this has been a serious problem in IT stuff in general since the 1980s, at least. And it makes me wonder if humanity is kind of approaching, its Peter Principle as a species right now. It seems like there's so much domain-specific knowledge required to create something that's even reasonably secure from an IT perspective that by the time you're not creating actual IT gear, the odds that you're going to end up with a secure design, they kind of approach zero, and that doesn't really seem to be changing a whole lot. I don't think the needle's moved on that much over the last several decades.
Yeah, and it's one of the things that Schneier talks about here is like in commercial software, we haven't figured out how to respond to just script kiddies and so on very well. And it turns out the military has not been putting in any more effort than the commercial people have. And they're being attacked by much more advanced adversaries. And he also even just talks about in 2018, there was a 29-country NATO exercise called Trident Juncture, and it got pretty screwed up by the Russians deploying some GPS jammers. It's like, well, if we can't handle just GPS not working a little bit, and we've never tried that in our own war games, it seems like we're kind of not taking this seriously enough.
Another thing he brings up is the reluctance to involve civilians in any of these war games and preparations. And it's sort of quite an insular approach to this, which ultimately is probably not a very good idea.
Right. Like, I can understand they don't want to tell people what vulnerabilities they know they have and kind of spread that knowledge around. But at the same time, yeah, there's all the ones they're not thinking about.
I'm not sure that security clearances are the issue there, because the thing is that the folks that are really doing the heavy lifting for IT in the military, at least in U.S. military, aren't in the military. They're contractors. And there's a pretty hard, bright line between what civilian contractors do and, what actual enlisted and commissioned military folks do. And an awful lot of the IT work is just not getting done at all by actual military personnel. So when you start talking about field games, you are very much predicating already that you're not going to have contractors around. They're not really going to be involved. You're just making do with, what your uniformed folks can do.
Yeah. So what Schneider's suggesting they do is basically introduce anarchy into their planning and their war games. In particular, literally D&D style, roll a dice, and whichever subsystem has that number, that's disabled now.
Chaos Monkey.
Yeah. Basically like the Netflix Chaos Monkey. Just at the beginning of every exercise, randomly decide one thing, and that doesn't work anymore. On top of anything you think you can attack to do to the enemy, assume they can do it back to you. But B, let's just try breaking things we don't even think we can break and see what happens when it doesn't work. Because if we have a full-on cyber war, do you think the hospital is still going to work? Like, we saw hospitals in Ireland get disabled by ransomware very easily.
Yeah, or gas pipelines.
Yeah, and gas pipelines and so on. Now imagine somebody's doing this on purpose and coordinatedly. Now, nothing works.
I don't think that was the best example, because the problem at a civilian hospital is it's packed full of civilians that are answering all kinds of email from all kinds of sources, and they're extremely vulnerable to phishing,
right,
let alone spear phishing. And once you start talking about a military hospital that's actually operating on or adjacent to a war zone, you've got a considerably higher awareness that, there is an enemy that we need to be aware of. And I don't want to set expectations too high for, our military personnel, but I do think you at least have some less likelihood that folks in a war zone in a hospital are going to be clicking the shiny link coming from, any kind of random bad English source that comes in.
But at the same time, if we're getting into a larger scale war, we're going to need the capacity of the civilian hospitals too.
Yeah.
And how much of the military depends on FedEx and UPS for shipping stuff? Not everything's going on its own C-17.
Possibly the better question becomes, at what point do conventional military become almost superfluous, because you can do more damage in a more controlled fashion, cheaper and better with cyber warfare than by actually sending troops somewhere. And also, with less of a perception of you as the foreign enemy monster. It's a lot easier to say, oh, well, no, that wasn't really us when, ransomware nails a hospital, than it is when you literally send 10,000 troops somewhere to blow shit up with guns and tanks.
I guess the one that I found the most interesting from the example from the Ukraine was when the Russians made a cell phone app for calculating the artillery azimuth and so on. And it turned out a bunch of people in the Ukrainian military were using it. And it was also feeding their GPS location back to the counter battery people. And then suddenly all their artillery was destroyed. And you just think it's like the problem with using reservists and so on is suddenly they were using the calculator on their phone to do the math for the artillery and giving away their location.
I think that might be the new replacement for don't start a land war in Asia.
Yeah.
Don't use the enemy's apps to sight in your artillery.
Okay, this episode is sponsored by Linode. Go to linode.com/25A and see why Linode has been voted the top infrastructure as a service provider by both G2 and TrustRadius. From their award-winning support offered 24/7, 365 to every level of user, to ease of use and setup, it's clear why developers have been trusting Linode for projects both big and small since 2003. Deploy your entire application stack with Linode's one-click app marketplace, or build it all from scratch and manage everything yourself with supported centralized tools like Terraform. Linode offers great price-to-performance value for all compute instances, including GPUs, as well as block storage, Kubernetes, and their upcoming bare metal release. Linode makes cloud computing fast, simple, and affordable, allowing you to focus on your projects, not your infrastructure. So go to linode.com/25A, create a free account with your Google or GitHub account or your email address, and you'll get $100 in credit. That's linode.com/25A. So there's been relatively big ZFS news over the last couple of weeks, and that is that RAID Z, or is it RAID Z, expansion is soon going to be a thing.
Yeah, after 4 years of being in the works, the pull request is open.
4 years of being in the works and at least 15 years of people crying and whining and demanding it.
It is definitely the most requested ZFS feature ever, which is interesting because it's definitely a home gamer feature, not an enterprise feature, but with sponsorship from the FreeBSD Foundation and Delphix and IX and a bunch of other people, it is finally done.
Matthew Ahrens appears to have done the majority of the work on it. The way that the ZFS expansion works, as usual, ZFS, it's a little more complicated than you might think at first blush. One of the most important things is that it reshapes the VDEV itself. It does not actually reshape the data on it exactly. It just sort of shuffles it around. And what I mean by that is, let's say that you have a 6-drive RAID Z2 VDEV. That means you broadly expect your records to be stored 6 blocks wide, 4 data blocks and 2 parity blocks. If you expand that to a 7-disk RAID Z2, your existing data will still be in 6 wide stripes with 4 data blocks, or I say blocks, I should be saying sectors, 4 data sectors and 2 parity sectors. If you want to actually reshape your existing data to accommodate the new full-size stripe width of 7 disks, you'll need to actually rewrite it. You can do that by replication. You can just replicate one data set to another data set on the same pool, then delete the old one and rename it. That's one way to do it. But I would strongly advise, and Senor Ahrens seemed very happy when I publicly strongly advised that most people don't bother with that. Just let ZFS be. It's fine. It's not really going to be hurting you to have undersized records on your VDEV because you already had tons of them. Anytime you write a metadata block, that's only going to be on a RAID Z2, 3 sectors wide, 1 data and 2 parity. So as you go up until you get to something big enough to evenly split, amongst all the drives in the array, you're going to have undersized records.
Exactly. Like you're saying, if you have even just a 4 kilobyte text file or a file that compresses down to 1 sector, it's just going to be a 3-sector thing. And that's one of the things that makes RAID Z interesting, is that it's dynamically allocated, unlike a RAID 5 or 6, where it's always going to be the full width. With ZFS, it doesn't have to be. And so, especially on wider ones, that can make quite a difference. So when you expand it, you add that 7th drive. The trick with ZFS is, in the block pointer, it says, the data for the file you want to look at is at this sector number within the VDEV. And then depending on the type of VDEV, like in a mirror, those will be basically the location on the physical disk, except offset by, the ZFS partition and the first 4 megabytes being for the ZFS label, but otherwise going to match up to the sector number on the hard drive. On a RAID Z, though, it's a little more complicated because you have basically a sector number within the RAID Z, and then that'll turn out to be on one of those 6 hard drives. So RAID Z expansion works without needing block pointer rewrite by making sure that that same sector number ends up containing that same data. But now that it's 7 disks wide, you have to reflow everything. So it's almost like you're writing a Word document and you change the width of the margin, and now all your paragraphs can be a little bit wider and all the words reflow. And so you actually, move, if you had your 6 wide, and then you add the 7th column, now the block that was in the 2nd row of the first disk moves up, and everything just keeps shifting 1 over. And after you do the first couple, which are a little complicated, then now there's enough gap that you can move entire rows at a time, and it gets fast, and it just works.
As usual, I would like to point out to Alan that our listeners cannot see him grabbing sectors and moving them around in the air with his hands.
Luckily, in the video, I think you linked in your article, Matt has some nice slides that diagram it better than my hands flailing around in the air anyway.
So for folks who actually understand what block pointer rewrite is, this should already be, pretty clear. For those who aren't super solid on that, it may help to realize that part of what we've been talking about is that we're not actually rewriting blocks at all. We're moving sectors around, not blocks. And the RAID-Z expansion code actually has no idea what sectors belong to what blocks. And I remember in ZFS terminology, a block means either a record on a data set or a vol block inside a zvol. And the expansion code does not know where the block boundaries actually are. It's just moving sectors. And the reason that it's moving them is so that you don't end up with something weird like 2 disks almost empty and a 7-drive RAID-Z that was almost full when you started. Once you're done with the RAID-Z expansion, even though all of your records or blocks are undersized, they will be evenly distributed amongst all the drives in the newly resized VDEV.
Yeah, one of the big bonuses of the way it works is that at the end, the 1 drive's worth of new free space is all contiguous at the end, completely unfragmented, because it's all one contiguous block of free space. Sadly, because, like you said, the RAID-Z expansion code doesn't know where blocks start and stop and so on, it doesn't help with the fragmentation on your existing data. But all the new space is one nice clean slab.
So you mentioned that this is not likely to be used in enterprise, and it's more of a kind of home user feature. Why is that?
Well, if you're an enterprise, you're not going to be farting around with some box that's got, 4 drives in it and you want to add a 5th. You're going to have a storage server and you're actually going to be planning your, at least I hope you will, you're going to be planning your storage. When you've got, so let's say you've got a storage box that's got, 45 drives in it. You've got that carved up into, 4 10-wide RAID Z2 and some spares. What good is being able to arbitrarily add a drive to one of those VDEVs going to do you? That's not the world that you're living in. You're doing planned storage and you're going to add a whole shelf most likely. Or if you started that server out, only half populated with 45 bays and you've only got, 20 some odd lit, then you're going to refill those additional bays, but you're going to do it in, 6 or 10 wide VDEVs like you had the first half of it in. So this whole idea of I want to be rebalancing and reshaping and, reconfiguring my data on the fly, that's just not really a good idea. Now, the thing that scares me is every time I write about this stuff, I get people who claim to be enterprise people talking about how, that's just a necessary thing. And you need to be able to just throw a drive in the sand at any given time. And I'm just I wish I knew where you worked so I could make sure to never have anything to do with it.
Yeah. So I guess to explain it to Joe, the alternative to this new feature is that if you had Jim's example where you had a 6-disk NAS, right? 4 data disks and 2 parity disks. So the parity spread around. Anyway, you had a 6-wide RAID-Z.
I never said parity disks. You said that, Alan.
Yeah, I know. Yes. So you had a 6-drive RAID-Z2. And you wanted to grow it without this RAID-Z expansion feature, basically what you had to do is buy 6 more drives and add a second VDEV. This has advantages in that it gives you more IOPS and so on. And that's what an enterprise would do. They would buy in whatever size their RAID-Z layout is. Or like Jim said, buy an entire second JBOD and fill, another 45 drives or whatever. But a home user, sometimes they want to just be able to add that 7th drive. Although at least half the home users I know already have their NAS having as many drives as the chassis will hold, and they're going to need a new chassis to add more drives anyway.
Mm.
Now, this also leads back into why I am constantly advising people, unless they absolutely positively know better and know exactly why they know better, I tell everybody you should be using mirrors instead of RAID-Z. Because if you're using mirrors, it becomes much easier to manage. You've got 8 bays in your server and you've got 4 disks in there now. Well, that's 2 mirror VDEVs. You want more capacity? Add another 2 drives. That's an extra mirror VDEV. It just drops right into the pool and you're ready to go and everything's good. Whereas if you're trying to populate or mostly populate, your one set of bays with a RAID-Z VDEV that almost reaches, that's when you're in that weird no man's land where you're I want to be able to just add one more disk.
Is this why it's taken so long for this feature to appear? Because it's ultimately not that useful?
Yes, because the ZFS was developed by folks who were looking to make something awesome for business use cases, and they designed it that way. And if it was useful to home users, that was nice, but that wasn't really where the thought process came from. And so, when you get hobbyists and home users, they're like, oh, I want to do this incredibly
ill-advised.
I'm sorry, folks. This is probably going to make some people mad, but yeah, I was going to say unprofessional, thing with your storage. It's not something that's really going to get the attention and the desire to complete that feature from a bunch of enterprise storage people who designed what was supposed to be this super awesome enterprise system.
Yeah. So like when I built a system for somebody who I knew didn't know better, they had bought a used server that had 12 drive bays, and they had 2 old NASs they were trying to consolidate and a couple of new drives. And so they had, I think, 3 different drive sizes too. I'm like, even though it's less space efficient, we're going to do this as all 2-pair mirrors. And the advantage of that is in the future, when you need more space, you buy whatever bigger drives are cheapest on Amazon that week, and you replace one at a time, one of these mirror pairs. And now you've just replaced some 3 terabyte drives with some 8 terabyte drives, and you have 5 terabyte more space. Now you just bought 2 8 terabyte drives and only got 5 extra terabytes of space, but it's fine. But it means you can buy 2 drives at a time and keep expanding one of the until you've replaced all the 3s with 8s and then all the 5s with 10s and whatever. And you just keep cycling it like that and have a lot more flexibility than if we had done it as, 2 RAID Zs of 6 drives each. Then, you'd have to buy 6 drives at a time or buy extra drives and not get the extra space. And it was just going to be a lot more complicated. And the mirrors also just give you a lot more performance for the IOPS.
Okay, this episode is sponsored by CBT Nuggets, training for IT professionals or anyone looking to build IT skills. Go to cbtnuggets.com/25admins and sign up for a 7-day free trial. The on-demand virtual labs mean you can build practical experience with the commands, config, scripts, and everything you need to get the most out of each course. Another standout feature is the accountability coaching service, available to all learners with a subscription, which gives you access to a real person who will help you craft a personalized learning plan and set goals, and will check in with you to keep you accountable. So start your free 7-day trial today at cbtnuggets.com/25admins. It includes unlimited access to all course materials, including virtual labs. That's cbtnuggets.com/25admins. Let's do some free consulting then. But first, thank you everyone who supports us with PayPal and Patreon. We really do appreciate that. If you want to join those people, you can go to 2.5admins.com/support. And remember, for $5 a month or more on Patreon, you can get an advert-free RSS feed. And if you want to send in your questions or feedback, show@2.5admins.com. So Sean writes, I had a question for you regarding IPv6. I recently was able to get IPv6 via my ISP, and the devices in my network now all have IPv6 addresses, but I've noticed a challenge. With IPv4, if I wanted to identify which machine was doing something, like spamming the in-home DNS server, I could log into the router and get the machine's host name from its IPv4 address, because many devices register their host name with the DHCP server. With IPv6, most devices auto-configure addresses instead of using DHCP, and often use privacy extensions that cause them to randomize their IP addresses every so often. For a small network, what's the easiest way to identify which IPv6 machine is which when their addresses change and they aren't registering host names with the router? Do I have to rely on MAC addresses, or is there an easier way?
Well, first off, you can't rely on the MAC addresses because a lot of your devices are going to be randomizing those periodically as well.
Really?
Yeah.
I guess it depends on the device.
Android phones and iPhones and iPads, all of those are doing address randomization now.
Yeah, because otherwise you can be tracked pretty easily using that. For V4, I usually depended on the ARP table, which is the mapping of IP address to MAC address. And the neighbor discovery table does the same thing for IPv6. But yeah, with the randomization, it gets a bit more complicated.
Particularly because, again, any machine that's randomizing its IP address under the guise of trying to provide its user with more privacy, it's almost certainly going to be doing that with its MAC address as well, unless you've gone in and hopefully most of those devices have a way to disable it. At least most Android devices do. I'm less certain about iOS. You can even frequently tell them, stop doing that on my home network, but continue doing it when I'm out and about in the world. But this is going to be a challenge for anybody who wants to maintain control over their home network, because you are literally pitting yourself against Google and Apple, who don't know or care that your home network is different from any random network you might happen to be on while you're, out and about. And their whole goal is to make it difficult to impossible to track and manage you. So that's going to apply on your LAN as much as it does anywhere else.
To make it hard for anybody except for them to track and manage you.
Which they're not doing, by that same way. It's an extension of the same basic kinds of challenges that we went through and are still going through from the big transition from HTTP to HTTPS traffic. When you've got end-to-end encryption, for better or worse, you can't centrally manage it. Back when everything was HTTP and, non-encrypted IMAP or POP3, it was very popular to, set up your router to do a centralized kind of, antivirus or malware scanning that would deep inspect every packet that went through it. If you trust whoever is managing your network, that can be quite convenient. But you give up the convenience of being able to centrally manage those things when you add the extra security of end-to-end encrypting everything so that you can't man in the middle it. So it's the same issue again here.
Yeah, and like on a wired network, you can maybe more easily map the MAC addresses back to which port they came from. And, that goes to a certain thing. But then when you mix in Wi-Fi, then it's, again, much harder to tell what device is what.
Well, on Wi-Fi, your access point controller will probably tell you that, assuming that you're running, proper APs like Ubiquities or TP-Links or whatever.
Right, but if the MAC address keeps changing, you're not going to know which device was the one that had that IP 20 minutes ago.
Oh, yeah. Good point. Yeah, we're right back.
So it's gotten complicated, and there's not a great way to be able to tell necessarily. But the MAC address will help you get, at least so far, especially like on a wired network, the switch, whether that's your router or a separate device, will be able to know which port that MAC address was coming from, and that can help narrow it down a lot. But you're more back to playing detective and just trying to circumstantially figure out, all right, well, these three things correlate, and so it was probably this one. The DHCP didn't always have everything. You can configure DHCP v6 if you really want it, but like Jim said, your best bet is to see if your devices that are doing the dynamic IPv6 addressing have the option to turn it off on your specific network so that you can track things more easily.
Software can sometimes be a solution for this as well. Like as an example, on most of my hosts, I install Samba even when I don't plan to do any actual sharing, because that gives me the option of doing a NetBIOS scan and just picking up host names that way. And so I can pretty trivially look at a local area network and say, okay, I've got 20 Linux hosts on here, and none of them are actually exposing any Samba shares, but they're all running, the NetBIOS NMBD, and thereby making their name available. So I can do an NBT scan of the local subnet and come up with a list of machine names associated with IP addresses.
Yeah, or you can even configure on the individual machines the LLDP, Link Layer Discovery Protocol, and it will cause all of the machines to output onto the network their host name basically to the switch. Of course, again, that probably doesn't work on a phone, but for your more fixed installation things, you can get a software LLDP daemon that will just keep telling the network on a sub-IP level that, hey, this device from this MAC address is this host name. I've used that just to help map which port is this device plugged into on my switch. Or, I'm looking at the switch and I see there's a lot of traffic coming out of port 6. Whose fault is that?
Right, well, we'd better get out of here then. Remember, show@2.5admins.com if you want to send us your feedback or your questions. You can find me on Twitter @Joe Ressington.
You can find Alan @AlanJude.
And Jim's @JRSSNet.
Well done. We'll see you next week.